AIA UTD. I think everyone already agrees with this. I don't think I'm convincing anyone of this. It's not like my idea or anything. People have been talking about it for many years now. There's just reasons to believe why this semester is the optimal time to start it, and I think that's what I'm going to talk about. I don't know. How are y'all? Yeah. Can everyone hear me? Hello?
Yes.
Oh yeah.
Okay.
I really
cool.
like this picture.
Yes. So that's what took me the longest, I think, out of any of this. I actually did that cow in ANSYS for sure, 100%. It was my senior design project.
How aerodynamic is it?
Pretty. Yeah, except for the udders. Udders, not so much. A lot of circulation around the udders.
I see that.
Any more circulation, there'll be milk coming out, you know?
Oh, gotcha.
So, okay. So wait, how do I go to the stream? Okay, so I haven't done a lessons learned thing yet, but I think it's pretty important to understand like what the model is going forward. I watched the general meeting video, and I do like a lot of the stuff that's happening this year. I mean, it's definitely like attributing to this time, which is like a really hard time. But you know, I think it's important to understand where AIAA is now, because we definitely had a different model, I guess, last year. Like, I remember saying at like the first general meeting that we wanted to act as like an aerospace incubator, right? Well, I mean, the projects that we made either have been incubated or are no longer existing. So I think we have like a crisis of identity right now, but that's a good thing because everyone's having a crisis of identity right now. And I think we can really like go on a path and really understand what the path is, which is the most important thing. So like, just generally speaking, right? Like DBF is its own organization, which was the plan, which is good. IREC is no longer, CANSAT, which happened 2 years ago, is no longer. We were the aerospace quote unquote incubator when there was nothing else, but now there is stuff, right? Like SEDS and DBF are student orgs that exist. And SEDS is like a very non-engineering professional org, and DBF is a very engineering professional org. So it's like, where do we fit in all of this? Like, what's our purpose, right? And something I'm gonna go back to a lot is like, what is the unique experience that someone can have in this organization? And last year, I think there was definitely a unique experience that was there. It's definitely 2 years ago, there was a unique experience. But I think as our scope got bigger, you know, it became harder to have like unity to an extent. I think we can really bring it all back together. One point I'm going to talk about a lot is like, if there's anything that we can do that another org, like let's say ASME, can slap their sticker on and say, this is our thing now, and no one would bat an eye because it's so general that anyone can do it, then I think we're really not fulfilling as high of a goal that we could be. And what I mean by that is like, I think the workshops that we're doing are fantastic, right? But I think they aren't. No one joins like an aerospace club specifically for I guess workshops in an extent. They want to have a pathway into this field, right? So I talked with David yesterday about, let's look at each grade level, like a freshman, a sophomore, a junior, a senior, and understand what unique experience that they have, right? And I think a lot of our stuff now is kind of geared towards underclassmen, which isn't a bad thing because there's a lot of underclassmen. But I think going forward, it's like, what are they going to be doing in the next couple of years? Why I put cons here: potential funding issue, talent issue, just because like our focus on competitions was a good and bad thing. Because when DBF became its own thing, sources of potential future funding also left. You know, like a lot of the people that were OG AIAA in my sophomore year are are now OG DBF people, right? And so like as they're becoming alumni and getting jobs, a lot of their money will go towards DBF, which isn't a bad thing. But I think the purpose of AIAA is an overall general, overarching organization, which still has a lot of importance in this university. So I think there is sources of funding that are kind of leaving overall aerospace talent. Talent issues definitely a thing in terms of a lot of the OG AIAA people are now OG DBF people, which isn't bad, but they took a lot of experience with them, right? So I think that's a good reason why a lot of our membership is underclassmen. But these are all potentials because I think we can provide a different experience going forward. Um, I didn't put together lessons learned for the past couple of months. I just like put this together this morning. I think we do really need to understand what we can learn from these three orgs that are operating on different extents or no longer existing, which isn't a bad thing. And I want to repeat that again. So like IREC definitely, costs for restaurant are really high, and that kind of limited the ability to small scale test, which my personal belief is that's where learning happens, is in small scale testing. And because costs were really high for the competition, we were playing a waiting game and not like a prototyping game. And that's where I reckon DBF kind of diverged, because with DBF, there's a lot of like small scale prototyping, and that's why people really enjoy the competition, right? But frankly, we just didn't have the funds to do what we wanted to do. Even if we wanted to do a small scale test of a rocket, that's a couple $1,000s, like that's really high for a little amount of learning. So there's definitely like a amount of learning versus cost graph here that we did a chart. The third point I had were like roles were assigned before role definitions. So like we had 3 PMs, right? But not a single PM enjoyed their position because it wasn't really defined, right? We kind of just arbitrarily assigned it because that's what a competition is expected to have, a PM position. But I think like my conversations with Aparna over the summer were definitely eye-opening, because a lot of her questions are, what am I doing? What am I doing? Because it wasn't defined, right? And I can take a lot of personal responsibility for that, because I opened the competition before creating an initial scope. So it's important. The takeaway here is it's important for people to know what they're doing, right? And they need to have the self-confidence to believe that they are the ones for this role. Fourth point, underclassmen with small experience with rocketry. Like not many people know a lot about rocketry. So we did rely on Rocket Justin a lot. And that was a good and bad thing, because Rocket Justin's definitely a smart guy, engineer, but it's a lot. It's a lot for one person to handle, right? I remember talking to him about how a couple freshmen came up to me and they were just like, I have no idea what I was doing. And I talked to Rocket Justin about that. And, it's hard to split his time because everything kind of relied on him. And that's kind of a trend with all of these, is aggregation, I guess, of understanding, which is hard because it's a competition. There's deadlines, so you can't spend a lot of time training people. Drone racing kind of had a similar thing, with Drone Justin. Drone Justin was just the god when it comes to drones, but not enough people were willing to sacrifice school so that they could pursue this, which was a concern. Many people didn't think it had anything to do with their engineering. So it's kind of hard, right? Because it's like a video game, and that's kind of how we pushed it. Is like, this is like a sports team, but at the end of the day, it's like not much engineering was done, and people always felt like this was a secondary thing. So those were definitely issues when it came to drone racing. Things that we could have done better were push ham licenses more, just to get that engineering element to it. If you get like a ham license, that definitely goes well in like interviews and stuff, because you have to take tests for it and you have to get like a certification for it. But the main thing were like costs were up to the individual. Once again, heavy individual cost with not much benefit. Last thing was rad. Definitely first semester was a pretty good semester, even though like the planes have a very urban dictionary definition of flight, but that's fine. That's okay. Um, the burden, I put Justin here, but I meant to say Long. Don't worry, I didn't forget you, Long. Burden was really high on me and Long. We were up most of the weekends putting out these packets, but at the end of the day, it became a class, which is not what its intention was. And that caused a lot of interest to be lost on both ends, both in me and Long and in the individuals, because it didn't become a workshop. It became a class, right? Me and Long weren't just people. We were Professor Long and Rahid, and right, and that's not a good thing, because we're still engineers and we're still learning. And um, there were a lot of moments where me and Long were questioning, like, do we even have the understanding to like properly teach this without them having to maybe relearn it later on. So, or not relearn it, unlearn certain things later on. Uh, and a lot of our costs were ballooned in the first semester. So we spent a lot of money on those planes. It was like 120 per team. So we didn't have any money coming into spring, which sucked. But Corona happened and everything kind of shit hit the fan. So last thing was, we relied too much on programs and not enough about understanding. And once again, this all comes down to how much do we need to push rad in terms of like uh, the class element to it, right? Like there's a lot of high level stuff here, and you need to have like a thorough understanding about everything. And there's a program that can easily do it, like RPA, CEA. But at the end of the day, is if someone plugs in numbers to RPA or CEA, they're not understanding what's happening there, and no one's learning anything. And I fell into this pitfall a lot, like in the past couple months, because um, it was a lot easier just to plug in numbers. At UTA, I spoke with a lot of people about this, and their solution is just to kind of do what we've been doing, which is like, not what we've been doing, but like what we did in Rad, which was just use a program, which kind of sucked. And there's a lot of unlearning happening right now at the UTA team, because they need to reduce their heavy reliance on programs. But I think this is something that's universal. Every engineer should know, like, they need to understand what's happening in this program before they can use it. But um, so what we need in a program going forward, right, is we need a program that can allow for small scale testing for cheap. And what that means is someone can 3D print a part, use a really cheap sensor, and code an Arduino, and basically get most things that they're setting out to do. An example is if I was printing out a tube and I was running water through it, could I use an Arduino, a fan, and I don't know, water flowing through it to determine what the frictional force of the wall is, right? And the answer is yes. It just takes a lot of time, but it's cheap as opposed to like a really expensive sensor that needs to be put in there. So we need to allow for small scale testing, because a lot of teams across the United States, that's all what they do, small scale test. We need something that can be done virtually. It looks like spring is probably going to be online, which sucks, but definitely UTA is going to be online next semester, which is maybe an indication that a lot of UT schools are switching over to the online platform next semester. Second wave never ended. So third point is we need to grow underclassmen from scratch to pursue projects and pursue a specific subject, right? Seniors and juniors are definitely intelligent and definitely should be involved in this process. But at the end of the day, I think what we have more than anything is a lot of underclassmen that are very passionate about something, and they kind of need mentorship to make their journey faster than our journey. So fourth point is a topic related to people's interests. The point I'm going to bring up is drone racing, right? Like, a lot of people like rotorcraft, but people here want to design rotorcraft, and that was a pretty big nail in the coffin there, because not many people were willing to sacrifice. So I looked at a couple of models of other schools. I've been asking around a lot. On the left is MIT, and on the right is Michigan. And what they do is they don't focus on competition teams at all for their rocket research divisions. And as a result, they don't have any set deadlines. And so they can focus a lot more on the actual learning element of it, which I think is very important, if not more important than a competition team. And what that results in is a lot of mentorship within the organization, which I think is really good. On the left is a project by a freshman from MIT. And I know what you're saying. Fucking MIT, of course they're from MIT. But they're just engineers just like us. I don't think there's any difference other than they pay more for their school than we do. But that's a freshman project. He's mentored by upperclassmen, and he made a little project with that rocket engine. And that rocket engine has 1 pound force of thrust, which doesn't seem like a lot, but there's a lot of engineering here. And that's the most important thing. By not focusing on competition models, we're avoiding the pitfall of going for the bigger, the better. We're going for the actual knowledge, which is the important part, right? And you can actually build upon previous experience. On the right is NASA's rocket that they launched like a year ago, or test fired a year ago. That produces like 2,000 pound force, which is crazy. That student undergraduate team did it, but it took 15 years for them to get there. So by not focusing on competition teams, we can set pretty long-term goals that are attainable, right? That's what I'm trying to go. So kind of the first steps that we need to do, I think the best way of doing this is if we ask for 10 sophomores, juniors, right? People that we can interview in the next like a couple weeks and just gauge their interest. So ideally people that want to work with launch vehicles, people that want to work with propulsion or avionics or something. But they need to be very invested, and we need to set the bar with them that they're going to see this through for the next couple years. And if this is what they really want to do, then they need to do it. I'm thinking the split is going to be 6 MEs and 4 ECEs, and I'll explain why in a second. The preferences on people that take in thermo, once again, we don't want to guide people to potentially have to unlearn things in the future. And they can spend 4 to 5 hours on independent research. So what we need to do is basically just interview these people, host like a weekly Q&A that their undergraduate minds are saying, or not underclassmen minds are going to be asking, like, what is enthalpy? What is temperature? What is pressure? How are they all related? People that, like, if you take in heat transfer, you probably already know. And then like put together guided research. And I'm not saying make packets. I'm not saying this at all, because I feel like a lot of this stuff can be self-taught using just resources online. So like YouTube playlists, specific textbook sections. And I have online copies for most of the textbooks. So I think we can just share those. And I made a bunch of YouTube playlists, and we can just share those. And then set like just a small list of weekly standards. Are people keeping up with it? Who's showing initiative? But the goal here is this semester will basically be kind of like an interview, a semester-long interview. And this is what they'll be doing. This is what their deliverable is. So 2 projects. So if they're mech, their only goal is to design an isentropic combustion chamber, which is not as hard as it looks. It's literally just this, which is just a basic CAD model. This has an injector. We probably wouldn't even ask for an injector. We'd ask them just to simply understand the fundamentals. What is isentropic? What are the isentropic relations between Mach and temperature, pressure, velocity, right? Kind of the stuff we were going into with RAD, but Corona put a dampener on it. And then just have them put them in MATLAB, very easy functions. It's not expecting as much as you think from people, because I think this can definitely be done in a good guided like 4 to 5 months, especially for a sophomore or junior. So I think this would actually be pretty doable for them. And their deliverable is a CAD model with their combustion chamber, a couple questions on why did they choose what they chose, and a look at their MATLAB plots and seeing why they did that. And then for the electrical and CE people, it's very important that they understand the basics of microcontrollers, relays, and signals. Because if they can understand that, then they can send a signal to a valve and have that actuate. And it's pretty straightforward from there. So their project is a very dumbed down version of that, which is basically take any microcontroller and stick it up to a couple resistors, relays, transistors, and an LED. And your only goal is to send a signal to that LED and have it light, and then send a signal back. and their MATLAB portion of it is to design like a user interface, so a button on their screen that says "Open Valve," and then the LED will light. And what it basically does is it allows them to scale up. So instead of using an Arduino, they can scale up to a Raspberry Pi. And instead of using an LED, they can use, a pneumatic controller or something, right? But it's scalable, and that's the point here, small scale testing. So we can buy a Raspberry Pi for like $10 at Micro Center and an LED for like 0.01 cents. So a lot of this stuff is really cheap. And honestly, they probably already have it because they're given it in like sophomore year. So these two projects, I think, this semester are an absolute must if we need to like train the next generation or whatever. So Liquid Rocket project, who's in charge? We shouldn't assign leadership positions. Absolutely not. Once again, I think this semester should be like an interview. So at the end of this semester, and I'm thinking like December, like 25th plus, like the very end of this year, we just have like kind of like mini exit interviews, and then we see like who is showing competency and passion and skills, right? Who's asking questions and wants to apply to these positions and be good at them. And these 10 people will take up leadership positions next year. And I think it should be kind of like we decide or y'all decide who the people that are going to be the leaders of next year are, and then they can decide what the structure of the team is and how it is going forward. But like a really basic timeline is like the end of this fall, we'll just decide who the leaders are and completion of these initial projects. Spring 21 is just designing the first draft of everything on CAD and doing like maybe a cold flow test, but these can all be pushed back depending on how the year goes. I'm assuming that it'll be in person, but if it's virtual, then obviously a cold flow is impossible unless you meet like an SPN, outside SPN or something. Fall 21, you rig a hot fire test or you weld a hot fire rig. And then spring 22, you do like basic hot fire. And then fall 22 is when test fire 1. So I'm talking about big chunks of time here, right? I'm not saying everything should be done in a year because it's not about speeding this process up as much as possible. Because while that's great, we do need to understand that learning takes time. You shouldn't rush learning because then you take shortcuts and you don't understand what's happening. And we're doing people disservices. So when they do a test fire, these leaders that we decide in fall 2020 should have a 1.5 to 2 years of experience by this time. They should be pretty familiar about this, which should mitigate a lot of safety issues. These are rough costs. These aren't really that followed, but I'm estimating that this fall should take less than $100. That is if they don't already have Raspberry Pis. If they have Raspberry Pis, it's $0. Spring 21 should be no more than 700, just because a lot of the parts that are going to be designed are 3D printed. A lot of the plumbing systems are going to be PVC, very cheapo, not going for clout right now. But then 21 and 22, fall 21, spring 22 is when costs may start going up because you actually have to buy metal and stuff. But it's spacing it out, which means we have to raise $5,000 in 2 years, which is definitely doable, especially if we take it slow. I think this is the last slide, but pitfalls. I think there will always be people that say, "Oh, we should go for 200. Why 200? We should go for 600." But this is a pitfall. Bigger. I put is better. I meant to say isn't better. That's a typo. But our goal should be pretty low for that first test fire in 2 years. It should be like 10 to 15. It shouldn't be crazy. We shouldn't be trying to push any envelopes or barriers. We should be trying to do the very minimum possible, because if we can do the very minimum possible at 100% what we model, then we actually understand it. If we increase the scope, that opens up so much entropy and it becomes unsustainable. Costs are going to get really high. The things that we can control are going to be so astronomical. They're going to be crazy. They're going to be cray. it's not a good goal. It's not a good plan, especially for this school, especially for the people that we're talking about. Goal should be low. Pitfall is deciding PM leaders too early. I talked about this before. I think if we train people or guide people this semester, it would kind of dissuade a lot of those concerns. Cryogenics is a pitfall. I've been looking up a lot of UTD professors. Usually at other schools, they have a professor or two that has like mega experience with cryo. I don't know of any UTD professors that have good experience with cryo, but I could be wrong. But this becomes like a safety thing, definitely a safety thing. So I would say that this is a pitfall. And instead of using like cryogenic oxygen or something, we should probably just stick to like ethanol or nitrous oxide or like gasoline even. Once again, going for the MVP here. Joining a competition is the biggest pitfall, because that creates set dates, that creates sacrificing broad learning for the goal, and that encourages shortcuts. And I don't think that model works for other schools. Even though a lot of them say, "Oh, we're going to go compete in the 1,000,000-foot competition or 100,000-foot competition or something." I just don't think that's a good way of approaching it. But that's my personal opinion. This can change, of course. I just think right now, with the people that we're dealing with, it's not a good idea. Not fundraising early. This is simple stuff. Just do a bake sale or whatever. But the main thing is not emphasizing on small scale testing or DIY projects is a big pitfall. Trying to purchase $300, $400 sensors that you could do with 2 months more time and $400 less is a way better course of action. And relying too heavily on programs. CEA and RPA are great tools, but at the end of the day, CEA does all the heat transfer for you. But what does that show that you know about heat transfer? If I was in an interview with Blue Origin and I was saying, "Oh, I just shoved that shit in RPA," they wouldn't care about that. They would say, "Get out of here! What are you doing? You don't actually understand it," and that is a big pitfall. And I have had to do a lot of unlearning about my heavy reliance on programs. Main thing is Jennifer's here, and Jennifer is one of 5 people at UTD with liquid rocket experience. So not utilizing her or involving her in any way is a big pitfall because she is leaving in December. And that experience is very invaluable. The experience you have with Fluid Impulse. There's a lot of learning here. I think that's it. But basically I'm saying we should open this and we need to plan it for the long term. We shouldn't be trying to go for short-term goals right now. So that's what I'm saying. Y'all should decide or debate or do whatever it is you do, but that's what I'm saying. I don't think anyone here is against it. It's just about execution. So if you have any Q&A about that, I guess I'm open now.